Hey everyone, and welcome. Today we're tackling a fun problem called maximum difference by remapping a digit. It sounds a little tricky, but we're going to break it down into simple, easy to understand steps. Let's get started. Alright, here's the core idea. We're given a number. Let's just call it num. We get to pick one of the digits that appears in this number, say the digit 1, and remap it to any other digit from 0 to 9. A key rule is that when we remap it, all occurrences of that digit change. Our final goal is to find the biggest possible difference between the largest number we can make and the smallest number we can make this way. Let's walk through an example to see how this works. Suppose our number is 11891. First, let's try to get the maximum possible value. To make a number as large as possible, we should try to change a digit to a 9. Which digit should we change? Well, to get the biggest bang for our buck, we should change the most significant digit, the one furthest to the left. In this case, that's a 1. So let's remap every 1 to a 9. That gives us 99899. Now for the minimum value. To make a number as small as possible, we should change a digit to a 0. Again, the most impactful digit to change is the first one. So we'll take that same first digit, 1, and remap all occurrences to 0. This turns our number into 00890, which is just 890. The final answer is the difference between these two. So what's the first approach that comes to mind? Well, we could just try everything, right? We could take the digit 0 and try remapping it to 0, then to 1, all the way to 9, then do the same for the digit 1, and so on. We would generate a whole bunch of new numbers and then find the biggest and smallest among them. But that feels a bit clunky and like a lot of unnecessary work. There's almost certainly a more direct or greedy way to think about it. And there is. Let's think greedily. To create the absolute largest number, our goal should be to make the most significant part of the number as big as possible. So we should scan from left to right and find the very first digit that isn't already a 9. Once we find it, we'll change all instances of that digit to a 9. This is our best move for the maximum value. For the minimum value, the logic is similar but simpler. To make the number as small as possible, we want to make the most significant digit a 0. So we just take whatever the very first digit of the number is and change all of its occurrences to 0. This greedy logic is much simpler and gets us straight to the answer. Alright, here is the complete Python code that implements our greedy strategy. I know it might look like a solid block of code, but don't worry, we're going to walk through each part, step by step, to see exactly how it works. Okay, let's start with finding the maximum value. First, we convert the number into a string, so we can easily look at its digits. Then, we loop through the digits of that string from left to right. We're looking for the very first digit that is not a 9. As soon as we find that digit, we take our original string and create a new one by replacing every single instance of that digit with a 9. Then we immediately break out of the loop, because we've already made the most powerful change possible. Now for the minimum value, which is even more straightforward. We already have our number as a string. All we need to do is identify the character we want to change. According to our strategy, that's always the very first digit. So we grab the character at the first position of the string. Then, we simply create our minimum value string by replacing every occurrence of that first digit with a 0. And finally, we put it all together. We take the string that represents our maximum value and convert it back into an actual number. We do the exact same thing for the minimum value string. Then, it's just a simple subtraction. We take the max number, subtract the min number, and return that difference. That's our final answer. So how efficient is this approach? It's really fast. The main work we do is looping through the digits of the number and then performing a replace operation. The time this takes is directly related to the length of the number, or how many digits it has. If we call that length lang from tanh operation, the time complexity is big O of langs. The same is true for memory. We create a couple of new strings that are about the same length as the input, so the space complexity is also big O of L. So let's quickly recap the main points. The key to solving this problem was to use a simple and effective greedy strategy. We didn't need to try every possibility. For the maximum value, we just found the first digit from the left that wasn't a 9, and changed all of its copies to a 9. And for the minimum value, we always targeted the very first digit and changed all of its copies to a 0. This direct approach gets us the right answer every time. Hope that breakdown made sense. If this video helped you understand the problem better, I'd really appreciate it if you hit the like button, subscribe for more Leetcode explanations, or drop a comment if you have any questions. And hey, if you're feeling extra generous, the Boba Fund is always open. Keep practicing, Keep coding, and I'll see you in the next one.